All right, so this is Math 1, and today is the 28th of February, 2020. We're going to talk about translations and reflections today. We're going to do 2 lessons in one day. So we're manipulating shapes and using transformations. A lot of this is done in computer graphics, so it's one of the reasons we're looking at it. When you hear the word translation, what do you think of? Do you think of languages? Do you think of taking a word from one language into another language? Moving it from Spanish into English or English into Spanish. In geometry, the word translate means to move something. So we're going to be moving objects around. And every time you move the cursor on your computer screen, that's actually a translation. And it's being done by the software. It's moving that little arrow around. Before we get too crazy, we're going to do a little dance. We're going to do the entire dance and the song, even though we're only going to learn about 2 of the pieces today. So stand up. Put your arms like this. We're going to go slowly, but we're going to be doing this a couple times. Translation, translation. See how we just moved our hands? Okay. Next one. Reflection, reflection, like a butterfly or something, right? Reflection, reflection. Next one. Rotation, rotation. Yes, Maddie's good at that one. That's like a cheer move, isn't it?
No, not really.
Yeah, it kind of is. It was when I taught. Okay, and then the last one is called the dilation, which is it's making it bigger. Making it bigger.
No.
So say it with me and do the dance. It's translation, translation, reflection, reflection, rotation, rotation, dilation, dilation. Again, translation, translation, reflection, reflection, rotation, rotation, dilation, dilation. Again, translation, translation, reflection, reflection, rotation, rotation, dilation, dilation. All right. In your notes, a translation is just a movement. Translation it just means move up, down, left, right. And I know my marker's dying, so let's get rid of that one. So a translation is just a movement of an object. Up, down, left, right. Translation is a movement. Up, down, left, right. I am going to translate this point. All you need in your notes right now is that piece. That's it. I'm going to translate this thing up 3 and left 4. Count with me. Up 3.
1, 2, 3.
Left 4.
1, 2, 3, 4.
I put the point right there. This point is called A prime. It differentiates it from A. So this point, in your notes, A becomes A prime. And I'm going to write into this A prime. That's how it's pronounced, or read. If it had 2 little apostrophes, it'd be called a double prime, A double prime. Okay, so yes, you're already going towards my jokes. So if it was originally called Optimus, after the movement, it would be called Optimus Prime. If it was originally called Amazon, after the move, it would be Amazon Prime. Yes, okay. Mr. Barre, so funny. Hey, that Amazon joke couldn't use that 15, 20 years ago. That's new material right there. I used that back in like 1988, that joke. And no one got it. Okay. So I just move it over. Now we're going to translate a segment. I just do it point by point. So we're going to do point A first. We're going to go down 3 and right 5. Count with me.
1, 2, 3. 1, 2, 3, 4, 5.
What's the name of that point?
A.
Nice. Do it with me.
1, 2, 3. 1, 2, 3, 4, 5.
What's the name of that point?
B prime.
Notice segment AB and A prime B prime. Are they the same length?
Yes.
Yes, they are the same length. If I have a segment, this is a yardstick. If I move it around, is it changing length? No, it's not. Unless I move it at light speed, in which case I think it does change length. I don't know if it gets bigger or smaller. Relativity. Okay. How about, I'm not messing with you. I really do think something with light speed changes the length of optics or something.
Yeah, it's probably just gonna snap.
Mr. Barre, did you know there was 2 moons?
All right, we're going to keep going with this lesson. Here's a triangle. We're going to translate it. Up 7 and 2 right. Up 7 and 2 right. Let's start with A. Ready? Count with me.
1, 2, 3, 4, 5, 6, 7. 1, 2.
There it is. What's the name of that point?
A prime.
Good. At this point, we could move the rest of the points, or we can actually just draw the figure off of that point. So I know it's here. So how far over do you want me to go?
2.
1, 2. Boom. What point is that?
B prime.
C prime. And then I need to go up. Count with me.
1, 2, 3, 4, 1.
Good. 1, 2, 3, 4, 1. And what's the name of that point?
B prime.
Notice this triangle and that triangle are the same triangle. They are congruent. They did not change. This and that are the same triangle, just moved around. Questions so far? Cool. Well, let's do reflections then. I think I'm done. Yep, I'm good enough. All right, if you do a Google image search using the word reflection, you get a bunch of cool pictures like this, like mountain lakes and mountains. So we're going to look at the math behind this. You could actually do a reflection using Photoshop, and it does the math that I'm going to show you, just at a much more complex level. So I need a mirror. This is my official mirror. It's not a mirror, it's a stick. And I need somebody that looks like me, and I feel like that's probably going to be Gordon. Come on, Gordon, get up here. Look, we're about the same height, right?
Close enough.
Yeah, close
I think
enough.
Trent's taller.
Turn us there.
All right. True. Take be about this far from the mirror. See that mirror? There, right? So if he's a foot from the mirror, I'm a foot from the mirror. Yeah. And if I go back one more foot, what would happen to my reflection? It would go back one more foot. And if I go back another foot, what would happen to my reflection? Is this how a mirror works?
Yes.
Right. And if I come forward, my reflection would come forward. If I come forward, my reflection would come forward. That's going to get awkward if I go forward. Okay.
Hello there.
I think I'm taller.
Yeah, probably by
At least my eyes are taller. Maybe my eyes are like really high in my head. Yeah, okay. So the idea is that, go ahead and take a seat. That if I'm 3 away, my reflection's 3 away. If I'm 5 away, my reflection's 5 away. So in a reflection, I am going to reflect this point across the x-axis. So across this axis. How far is this point from the mirror? Count with me.
1, 2,
So how far is the other point?
2.
And what's the name of that point?
A prime.
A prime. On your notes, we're going to write something down.
Oh, fun.
Reflection. Reflection. Walk to the mirror. Walk through the mirror. Which one I say that, it reminds me of Alice in Wonderland
Oh, yeah.
through the looking glass. So what I'm saying is that, hey, this point is going to walk to the mirror. Count with me.
1, 2,
Now walking through the mirror,
1, 2.
that's how I do a reflection. We're going to reflect this segment. Show me with your arm, which way does the mirror go for this? You have options of this or this.
What?
So,
Oh, yeah.
because I got to think where, because the mirror could be at different places. So the mirror is actually the y-axis. This is what I'm reflecting across. Walk to the mirror. Count with me. Count with me.
1, 2.
There it is. What's the name of this?
A prime.
Walk to the mirror. Count with me.
1, 2, 3, 4.
Through the mirror.
1, 2, 3, 4.
Name of the point.
B prime.
Did this segment change length?
No.
It is the same segment. It's just been reflected across the y-axis. If this is 3 centimeters long, how long is this?
3 centimeters.
If this is 8?
8.
Good. Show me with your arms, which way does the mirror go on this one? Good. The mirror is the x-axis. We're going to reflect it across that line, point by point. Walk to the mirror. Count with me.
1, 2, 3, 4, 5.
Through the mirror.
1, 2, 3, 4, 5.
Good. What's the name of that point?
8, 9.
Count with me.
1, 2, 1, 2.
Nice. What's the name of it?
C prime.
Count with me.
1, 2, 3. 1, 2, 3.
Name of the point?
B prime.
Boom, boom, boom. These are the same triangle. They are congruent. It's just been reflected. It's been flipped over. They are, yep. They are the same triangle. It's just been flipped over. Read this and using your arm, tell me which way the mirror goes. We got look at your neighbors. Yeah, you guys come to an agreement because I've got too many different answers going on.
It's like because it's why. Oh,
Y
wait.
goes down.
No, but if you see, if you think
It's
about it, it's a
3 y, otherwise it was
cross.
cross.
You wouldn't
And
be
it
able
was
to
cross.
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 Because if it was x, 3 y,
Yeah.
then
Come
then
to one listen. At Y, but it's this hat.
All right, fish. Oh, you're going. Okay, Jackson, get up here, and then Greenlee, get up here. Convince us.
I know what it is. Great. I think.
Grab a marker.
Dude,
I thought it was like that.
Dude, it's like this.
So where do you think the axis is, Greenlee?
It's like this.
Like this.
It's like this.
And where do you think it is, Jackson?
It's crazy.
How would that work?
So you just think it's the y-axis, but it's not saying that. It's saying across y equals 3.
So yeah, y equals 3, and then that's basically the new x.
So this is coming. She's right. This is coming back
I feel like
to knowing how to graph lines. We've graphed this horizontal line before. Probably not.
I don't think so.
Oh, translations? Maybe. But the idea of graphing a horizontal and vertical line, we've done this before. This is part of our y equals mx plus b stuff that we did.
we did do 6
Yep. So this is y equals 3. Walk to the line. Count with me.
1, 2, 3.
Through the line.
1, 2, 3.
There we go. What's the name of this point?
A prime.
A prime.
Oh, okay.
Yeah.
So it's remembering how to graph y equals 3. This one, using your arms, show me which way the mirror is going to go. Which way is the mirror going to go on this one?
Yeah.
Good. It's at x equals -2, so it's right here. It's drawing in the mirror. Count with me.
1, 2. 1, 2.
What's the name of it?
B prime.
Count with me.
1, 2, 3, 4. 1, 2,
Name of the prime? Oh, A prime.
AB prime.
No. All right. Is this the exact same length?
Yes.
Yes, this is the same length, even though we've reflected across x equals -2. All right. Show me with your arms. Where is the mirror? Y equals 2. It looks like this at y equals 2. Count with me, Trent. Just Trent.
1, 2, 3, 4.
Through it.
1, 2, 3, 4.
Name of it.
A prime.
Nice. Greenlee, count with me.
1.
What's the name of it?
C prime.
Good. Count with me, Presley.
1.
What's the name of it?
B prime.
B prime. These two triangles are the same triangle. They are congruent to each other. They're the exact same size and shape. One's just been flipped around. Number 21, using your arms, show me the axis of reflection. Show me the mirror. This is a good one.
Mine only goes to 16 slides.
Number 21?
You're on the
I
wrong
think you're
one.
on
Oh,
translations,
yeah.
not reflections.
No, he's on reflections.
No, he's on translations. Or he's on.
Oh
You're
no,
on-
no, he was on translation still.
We're on reflections now. We switched.
Oh,
It goes like this. That's why nothing matched up for the
I was
last
like-
5 minutes of your life.
oh, hold on.
X equals -3.
Wait, what?
I wanna
Point by point. Gavin, count with me. Walk to the mirror. Walk through the mirror. What's the name of this point? Gavin, again. Walk to the mirror. Walk through the mirror. What's the name of this point?
It's just flicking it.
Yeah.
B. Maddie, walk to the mirror.
1.
Walk through it. What's the name of it?
B prime.
B prime. There's the axis. There's the reflected shape. These shapes are congruent. They are identical in shape and size. If I flipped them around and put them right on top of each other, you would see they are the same triangle, just flipped over. Cool. Normally, this is 2 days worth of material for when I teach it to Math 8. You're doing it in 1 day. Normally this would be 40 minutes worth of homework. Today, I'm going to drop it down to 15 and 15. 15 minutes of the two each on the IXLs. You have enough time in class to do this if you will work diligently.
If you get 100%.
It's either 15 or 100%, yes. That's it. It's 2 IXLs, one dealing with reflections, one dealing with translations. It should totally match with what we just did.